Welcome everyone to the course called Design of Reinforced Cement Concrete Structure, as the reinforced cement concrete structure is one of the important material which is to be used in construction industry and are rigorously used and practiced from many centuries in various parts of the world, because it is an economical and cheap material and durable material which can be used for the suitable purposes for the human being and the shelter nature in the civil engineering and the construction field of industry. Coming on to the course outcomes, what are you going to learn in this particular course means what you are will be familiar about at the end of the course. One, you will be able to explain the properties of fresh and hardened concrete, as when you complete the particular course of CT and RCC, that is construction technology and reinforced cement concrete course, you will be able to explain the properties of fresh and hardened concrete. And second outcome is you will be able to explain different types of concrete and concept of pre-stressed concrete, methods of pre-stressing. The civil engineering industry has got major advanced and modern technologies which are being used for construction purposes, for the transportation and the shelter purposes, where pre-stressed concrete and pre-stressing plays a very important role in nowadays construction. Third outcome will be you will be able to illustrate concept involved in limit state design, analysis and design procedure of singly reinforced beams. And fourth outcome is you will be able to analyze and design of doubly reinforced beam and T-beam also. Fifth outcome will be design of one-way slab, two-way slab and cantilever slab. Sixth outcome is design procedure involved in column and footing. So all these outcomes, when you will be able to, when you are at the verge of completion of this particular course, you will be able to design each and every structural element which is being used for a building or any civil engineering structures. Coming on to introduction, reinforcement concrete as a composite material has occupied a special place in the modern construction of different types of structures due to its several advantages. Various advantages are involved in order it can be used for any different kinds of material in any different situation. These are the reinforcement concretes plays a very vital role due to its flexibility in form and superiority in performances. It has replaced a large extent the earlier materials like stone, timber and steel. Further, architect's scope and imagination have widened to great extent to its moldability and monolithicity. Means you can change the material in any shape you want and you can make it however you want. So these with the help of the architect and the structural engineers, you will be able to do such type of the particular shape for the concrete. The design of those modern reinforced concrete structure may appear to be highly complex. However, most of these structures are assembly of several structural elements such as beams, column, slabs, walls and foundation. Accordingly, the designer has to learn the design of these basic reinforced concrete elements, the joint and connection are carefully developed. In any engineering structure, the major parts of the building are like the slab, the column, the beam, and the walls, and foundations. There are these many structural elements which needs to be designed, and the limit state method through an empirical approach has got us an important procedure or process to be followed at the time of any designing of a reinforced concrete structure started in beginning of century, following purely empirical approach, that is the working stress method and ultimate load method were generally used. In 20th century, they came to know that limit state method would be the best possible method after many experiments were conducted around the world. Thereafter came to called as rigorous elastic theory, where the levels of stresses in concrete and steel are limited so that stress deformation are taken to be linear. However, the limit state method through semi-empirical approach has been found to be the best of designed reinforced concrete structures, and we are going to study about the limit state method, which has been used in almost all construction structural designing part of civil engineering. There are though some of the constraints and applicabilities of both the methods that will be discussed later in our coming classes. And coming on to the objectives, there are objectives of the design of reinforced concrete structures. Like every structure has got its own form, functions and aesthetics are there. Normally, we consider that architects will take care of them and the structural engineers will be solely responsible for the strength and safety of structure. However, the roles of architects and structural engineers are very much interactive, and uniformed approach of both will only result in integrated structure, where every material of total structure takes part effectively from functions and aesthetics. Functions, what function is the building going to serve, and what is the design or the appearance of that particular building or a element or a structural element to be considered, and also the strength and as well as safety and durability should be considered at the time of design for the structural element. This is possible when architects have some basic understandings of structural design, and the structural engineers also have basic knowledge of architectural requirement. Means the structural engineers should know what and all are the architectural requirement, and architectural engineer should also have a knowledge of structural elements which are to be located in particular area. So both the engineers and the architect should realize that skeletal structure without architecture is barren, and merely a architecture without the structural strength and safety is disastrous. So, the structural element should be taken care at the time of design. And also safety plays a very important role here, which includes consideration of reverse strength, limited deformation and durability. However, some basic knowledge of architectural and structural requirement would facilitate to appreciate the possibilities and limitations of exploiting the reinforced concrete material for the design of innovative structures. And before proceeding to the design, one should know the objectives of design of the concrete structure. The objective of the design are like: 1. The structure so designed should have an acceptable probability of performing satisfactorily during their intended life. Means the object does not include a guarantee that every structure must perform satisfactorily during its intended life. There are uncertainties in the design process, both in the estimation of loads likely to be applied on the structure and its strength of material. Moreover, full guarantee would only involve more cost. There is an acceptable probability of performance of structure as given in standard code of practice of different countries. Various countries have got their own codes which is to be followed with respect to the government authentication in their region. So, this is a very important objectives considering for the safety, satisfactory and estimation of various load which has to be designed at the time of the which has to be considered at the time of design. Coming on to the second objective, the design structure should sustain all loads and deform within limits and its use. Here, an adequate strength and limited deformation are the two requirements of the design structure. The structure should have sufficient strength and deformation must be within precise limits. Means all the loads during construction and use as seen in various conditions. The structure having insufficient strength of concrete which fails in bending compression with the increase of load through the deformation of the structure is not alarming on other hand. So, when you are considering any type of or constructing any type of the building or the beam or structural element, if there are enough load coming on it, it should either withstand within the deflection in other condition. If there are heavy loads coming upon it or same kind of load A is coming upon it, the material will break with respect to its bending moment, or the material or the structural element, if it is loaded with the same loadings, that is A, the material will go to its full deflection where this faces a problem. So, all these three conditions should be rigorously thought or considered before designing any kind of structure. However, sometimes structures are heavily loaded beyond control. Okay, when it is loaded beyond control, the structural engineer is not responsible to ensure the strength and deformation within limit under such situation. Example, the staircase in residential building during the festival or like marriage, etc., and roof of the structure during the flood in adjoining areas of the building near some stadium or the cricket or football stadium. When it is overloaded, there are chances of the material or the structural element getting more deflected. And so we have to ensure that failure of structure should give sufficient time for the occupants to vacate the structure, thus should give sufficient warning to the occupants and must not fail suddenly. So these are the three important designs which has to be considered or which has to be kept in mind while we are doing any kind of design. And the design of structure should be durable. How it should be durable? How the durability occurs? The design structure should be durable, means the material of reinforced concrete structures will get affected by the environment conditions. Thus, the structure should have or having sufficient strength and permissible deformation may have lower strength and that will exhibit excessive deformation in long run. For example, if there is a concrete RCC or reinforced cement concrete, after 100 years there may be some creep or some deformation or deflection occurred due to its own weight. Okay, so that has to be considered at the time of design, and separate checks for durability are needed for the steel reinforcement and concrete as well, and this will avoid the problem of frequent repairing of the structure. The design of the structure should be durable, and also the material which are being used in particular construction should be well versed and it should be durable within all the permissible limits and standards as per IS 456 and a standard as per material testing standards. And coming on to the next objective is the design structure should be adequately resist to the effect of misuse and fire. Structure may be misused to prepare firework or store firework or gas and other highly inflammable or explosive chemicals. So what should we do is, fire may also takes place and or accidents or a sudden effects during earthquake or by overturning of kerosene stoves or lantern or electrical short circuiting properties which we generally accommodate at a house. The proper design structure should allow sufficient time and safe route for the person inside to vacate the structure before the actual collapse will happen. For this we need to study the building bylaws which are being provided according to the Indian standards. So how will we fulfill all these objectives? We need to have a sufficient knowledge to fulfill all these objectives of functional integrated structures, or to have its strength and good safety and durability. And safety and durability includes the consideration of reverse strength, and we should look for the intended life of the structure, and all loads should be considered, and it should be durable, and the critical area where fire and gas or fireworks building, there we should take a important considerations in order to fulfill the objectives. All the objectives above can be fulfilled by understanding the strength and deformation characteristics of material used in design, as also there is a deterioration under hostile exposure like environmental loads or the temperature or the rainy season or cold conditions. There are the deterioration which will happen out of two basic materials, concrete and steel. The steel is produced in industry. Further, it is available in form of standard bars and rods of specific diameter. However, sample testing and checking are important to ensure the quality of these steel bars or rods. The concrete, on the other hand, is prepared from several materials such as cement, sand, coarse aggregate, water and admixture, if any. If it is important to know the characteristic properties of each of these material which is used to prepare the concrete, for this to know the material characteristics and property, as we have studied in our previous semester, the construction technology, materials of construction and concrete technology, what we have studied the various important properties which has to be there in which has to be considered, or which should be within the permissible limit for which is being used for construction. So these materials and the concrete after its preparation are also to be tested and checked to ensure the quality of the same. With the necessary information regarding the properties and characteristic strength of these materials are available in standard codes of practice from different countries. India will go with Indian National Building Code, and IS 456/2000 is the latest version which is being used, or it is kept in practice in India. It is necessary to follow this clearly defined standard for material and production and workmanship and maintenance and the performance of the structure in service at the time of construction and of post construction, this post construction method. And while coming to the method of design, which is an very important factor when you consider the RCC. Three methods of design are accepted, including the clause of IS 456/2000 Indian Standard Plain and Reinforced Concrete Code of Practice is generally practiced by in India, and which is published by Bureau of Indian Standard, which is there at New Delhi. So these are the authority. Bureau of Indian Standard is a authority which regulates and make any changes and issue of all the Indian codes which are being used for any construction activities. Generally, there are three different methods which are being in use from past many decades, in which today we are simply using, or the only method which is being used, or maximum of 99% the method which is being used is limit state. Earlier there was working stress method which was being used due to some unfactor or unsafe conditions of, or the unsafe practice, or the unsafe experience which have been taken all over the world. Working stress method is been used for some areas only, and the method based on experimental approach is also there, and these are the some three important which is been used. Now what is the term limit state? What is meant by limit state is a continental origin where there are three limit states. One is serviceability and crack opening and collapse. For reasons not very clear, in limit state of collapse, it is termed as limit state method. As we have discussed earlier, the semi-empirical limit state method of design has been found to be the best of the design of reinforced concrete members. And further we are going to study about this in detail. Now we are going to just know what is the importance of this limit state. A limit state is an condition of a structure beyond which it's no longer fulfill the relevant design criteria. The condition may refer to the degree of loading or the action of the structure, while criteria refer to structural integrity. One is structural integrity, fitness for use, that is serviceability, and durability or other design requirements. So limit state method is one which will tell us before the collapsing of a particular structure, and the design will be economical design, and factor of safety will be high considered here. So this particular method is mostly used in various parts of the world. In IS 456/2000, it is been thoroughly updated in its 4th revision in 2000, taking into consideration the rapid development in the field of concrete technology and incorporating important aspects like durability, serviceability and structural integrity, etc. The standard has been put greater emphasis to limit state method of design by preparing it in a full section, and whereas the working stress method has been in a same standard. Accordingly, structures or structural element shall normally be designed with the limit state method. So the working stress method is considered as method of earlier times. When we come for the working stress method, has been several limitations in a situation where limit state method cannot be conveniently applied. Working stress method can be employed as an alternative. Example, in the design of silos or water tanks, we generally use working stress method, and which is generally is still in practice in various parts of our country. And there is the method based on experimental approach. The design may be performed, experimental investigation will be made, and module of full size structure or elements, and accordingly the design or elements. However, the four objectives of the structural design must be satisfied when designed by employing this approach. The four objectives will be such as: the structure for designing should have the performing satisfactory during their intended life, and it should be the loads and deform within the limit of construction use, and it should also be designed for durability, and it should also be adequately resist the effect of misuse of fire. So these four objectives should be covered. So once we do the experiment on a particular material, practically, and then this material will be used for any particular purpose, whether if it is for fireworks, or if it is underwater works, or if it is exposed for the extreme condition of different environmental impacts. And though the choice of method of design is still left to a designer, this is not generally practiced, but still the designer, if he is interested in doing this particular design process, then he can generally use it. So this method of working stress will be used for some extent, and method on experimental approach is completely ruled out. Now, what are the difference between the limit state method and working stress method of design? So, working stress method, in this, it is based on elastic theory, which assumes that concrete and steel are elastic and the stress strain curve is linear for both. Means the elastic theory which says that the concrete and steel both are elastic, and the curve which is there with respect to stress and strain, which is linear. Okay. So the material here, in this particular theory, the material here which is being used for this particular design or construction, as we know that concrete and steel has got different properties. Like for example, one it is hard in, means it is good in tension and weak in compression, and concrete is good for compression and weak in tension, whereas the steel is both good for compression as well as tension. So linear theory or elastic theory, where the stress strain curve is linear, will not hold good. Okay, so the same parameter and criteria, when we come for limit state method, this is based on actual stress strain curve of steel and concrete. For concrete, the stress strain curve is not linear, means the stress and strain will not linear. It will be linear for some extent, and it takes its own the shape after it reaches a particular permissible limits. So this is based on elastic theory, and what we consider here it as the stress and strain diagram for, or the stress versus strain for material is considered to be as linear, and it is elastic. Here actual stress and strain for concrete and steel is separately taken with respect to the lab results. And coming on to the second point, working stress method, factor of safety are applied to yield stress to get permissible stresses. See, factor of safety here, it is applied to the yield stress to get permissible stresses, whereas a partial safety factors are applied to get a designed value of stresses in limit state method. So here the yield stress is considered, here the factor of safety is considered as per IS 456, and no factors of safety is used for load. In working stress method, there is no factor of safety used, whereas in limit state method, design loads are obtained by multiplying partial safety factor of loads to be working, and also this is been given in IS 456, okay, for more details. And exact margin of safety is not known. Safety margin will not be known in this one, whereas the safety margin is known in limit state method. Whereas in working stress method, this will give a thicker section, so it is less economical, because here we consider the steel and concrete both are linear. So for that reason we consider the section will be very thicker. In this method it is more economical and it gives very thinner section. If there are modulations happening within the concrete and steel, okay, then we can definitely make the section very thinner in limit state method, and we can also make it economical by low cost. Here if it is thicker and it will be less economical. And in working stress method assumes that actual load, permissible stress and factor of safety are known, so it is called as deterministic method. Okay, means we are assuming that actual load and permissible stresses and factor of safety is known, but in it is based on the probabilities and approach which depend upon the actual data or experience. Here it is called as non-deterministic method. So these are the 6 important differences between the limit state method of design and the working stress method of design. In working stress method, factor of safety applied to the yield or ultimate strength to get a permissible strength, and structure designed to support the working load without exceeding the permissible stresses in concrete and steel. Inadequacy of elastic theory, that is actual safety against ultimate load, is not known in working stress method, whereas in the limit state method, the structure design is to satisfy the limit state, for example in strength and collapse, and serviceability, deflection and cracking, which is in limit state method. Statistical probabilities are concepts incorporated for loads and strength. So the various loads and strength of steel and concrete and characteristics loads and strength which are obtained by applying partial safety factors for load and material strength, and limit state method overcomes the inadequacies in working stress method and ultimate load method. Limit state method is incorporated in most of the national codes of various countries in American, European and Asian countries. When coming to the ultimate load method, after elastic method, ultimate load design method was introduced. In this method, inelastic or plastic behavior of the concrete and steel are considered. What happens? Load factors applied to working load to estimate the ultimate load, and factor of safety is applied to characteristic strength to estimate the design strength, and the inadequacy of ultimate load method, serviceability and aspects of deflection and cracking at various loads which are not considered, and the deflection and cracking effect under working load condition were not considered in this particular method. So these are the 3 important method, whereas 2 methods are merely outdated and 1 method which is there, which has been in practice. Now what are the applications? When we come for application part of reinforced concrete, has more or less replaced steel or primary construction material, mainly due to its universal adaptability is there, versatility is there, coupled with the resistance to fire and wind and corrosion result in negligible maintenance cost. The primary application of reinforced concrete as an economical structural material is various types of various types of structure are described like the horizontal structure like slabs and beam of different types such as simply supported beams, continuous, flat, grid, coffered slab, T and continuous beams, which are the major applications. The second major applications are like vertical structural elements like column, piers, abutments and towers and pile-ons. When we come for curved structure, elements, domes and shell of different shapes, soil retaining structures like counterfort type and cantilever retaining wall, where on the either side the soil pressure will be coming on a particular retaining wall, okay, which has been there. And water storage structures are also there, which is below the ground level and some are above the ground level or on the top of the building. For these purposes, the application of reinforcement cement concrete are there, and transmission structures which are like electrical poles and energy structures which are like chimneys, cooling towers and thermal stations are also there, and rigorously used for railway tracks support elements like sleeper, which has been used to support the track, and reinforcement concrete rock bearing for supporting bridge girders are also there, box culverts are also there, and water transmission structures like pipes and adequates are also there. So these are all the important applications of the reinforcement cement concrete which are generally used in the cities and rural places of various parts of world and country, and this will be in use for many decades in future, but for next 25 years there are lot of work which needs to be happened in this particular application area of the reinforcement cement concrete, example of the channel, dams and other major construction which we are going to do in future. Coming on to national codes and handbooks. In most of the developed countries, they have prescribed a specific national code based on extensive research and practical knowledge. These codes serve as a guideline for design of reinforced concrete structure, and the principal objectives of the code are summarized. One is the provision of adequate safety by ensuring the strength, serviceability and durability. Codifying design procedure, design tables to facilitate easy computations, and so these are the main principal objectives why the code should be used. When we come for the second point, protection of structural engineers from an liability due to failure of structures, we should maintain, or we should keep in our mind, if there are any failure of structure, there will be a huge loss to the country and the people, and it is also estimated that every year there are 2,600 people who will die because of failure of structure. and which of this will be caused due to the insufficient use of the code books or handbooks, or if there is no proper use is been made, and if there are construction of some uneconomical structures, okay, then we need to fail this kind of problem. So we should be do an adequate design and use proper material and proper supervision during construction is required in order to maintain or in order to eliminate the failure of structure. And 3, there should be a uniform set of design guidelines to be followed. Design guidelines should be followed all over the country. So for that reason, the National Building Code and handbooks should be used and practiced when studying or designing any kind of structure. And it is also a simple procedure to do this kind of procedure will be simple. You need not go and search for any kind of the material, because once you go for this IS code book, you will get every inch of details regarding all the materials and total structure of construction. The National Building Code are periodically revised and which is reflects the improvements in the quality of material and design practice evolved as a result of comprehensive research investigation conducted in various institutions in the country and abroad. In India, design of reinforced concrete structure conform to Indian National Code, which is IS 456, which was recently revised, IS 456 2000, which was recently revised 9th time. The corresponding national codes of various countries are also there. For example, British standards are also available, American code is available, Association of Australia, Standard Association of Australia is available, and Canadian Standard Association, Toronto. Okay, these are also available, and other than these are all the various handbooks or the codes which has been practiced in various other countries. And in addition to this one, the special publication and a handbook are very useful in design of Office of Structural Engineers. Those are SP 16, which is used for steel, and SP 34, and SP 10262, which is recommended guidelines for concrete mixed design, 10262. These are the some of the important other code book which has to be used for the design. And standard loading conditions, what and all are the different types of load which has to be considered while designing any kind of the structural elements are. The design of reinforced concrete structural elements requires a knowledge of various types of load which is acting on a member, The various types of load which are to be considered are one is the dead load. Okay, dead load will comprise the self weight of the material that is used in construction, such as brick, stone, concrete, wood and other various material. The unit weight of most of the commonly used material are specified in Indian National Standard Code of IS 857. IS 875 and which is 1987. And live or imposed loads. Live or imposed load are a transient load changing with the time due to people using the structure. These are prescribed in IS 875 1987 part 2 and are given in table which is there in further slides. And wind load should also be considered. The wind load which is acting on the structure depend upon the location of structure in India is specified in same IS 875 1987 part 3. And for multi-story structure, water tank, tower, chimney and other types of tall structure, wind load should be considered in design. Wind load acting on structure are influenced by the plan, dimension, height of structure. Location of the design wind pressure are specified in Indian Standard Code. Wind load should be considered. Snow loads are also there. I don't know whether it is being used or in the south region. It will be definitely used in the north region. In the location where snow is encountered, structure located in such a zone have to be designed to resist the snow load prevailing its region and also various load combinations. The snow load are prescribed in same code, that is IS 875 1987 part 4, and special loads and their combination are specified in the same IS code. Snow load should be considered and various empirical formulas are also there to consider this one. And seismic load or earthquake load is a very important load to be considered in the design of structure located in specific zone of the earthquake region. In India as a subcontinent which experience earthquake resulting in lateral load of structure based on seismic study. And also India is been divided into 5 different zone where we need to consider different loading structures or seismic or earthquake loads for design purposes. And when we come for materials for RCC, there are different grades of material, okay, which is in respect to Indian National Code, Indian Standard of 456 2000 concrete mix. Proportion should be selected such that to ensure the workability and durability. And most commonly used grades of concrete is M20, M20 and M30. The revised IS 456 2000 prescribed M20 as a minimum grade for RCC, while M10 and M15 grade should be used for plain cement concrete. And tensile strength of the concrete should be considered okay, which is very minimum. When we come for the grade of concrete which are available from M15, 20, 25, 30 and M40, and above that it is called as the design mix. And in the same manner, if we the steel also should have different zones and type, and steel bars of different types of strength are used to RCC and in tension zone or flexural member to resist tension, since the concrete is weak in tension and in member subjected to compression to enhance the load carrying capacity. Four main types of steel reinforcement should be there, are generally practiced. One is mild steel and medium tensile steel bar, which is as per specification IS 432 part 1, and HYST bar, high yield strength deformed bars, okay, are used, and for that particular specification is IS 1786 1985, which is used over 90% overdue to ribs on the surface, which is generally which is used. The permissible strengths which have been used are 415, Fe 415. This the steel which is to be used will be hard drawn steel wire fabric, and the specification for this one will be IS 1566 1982, and structural steel conforming to a grade of A10 IS 2062, and which will cover which will also cover the roll steel joist sections in steel. Generally, the diameter which is been available are 5, 6, 8, 10, 12, 16, 18, 20, 22, 25, 28, 32 and 36 are the diameter available. Grade available are Fe 250, where this is the outdated. Fe 4 and 5 are generally used. Fe 500 is used for high heavy constructions. There are some of the properties of concrete depending upon individual properties of cement and sand, gravel, water and admixture should be there. Characteristics of and strength and properties of concrete to be considered with respect to the character strength is defined as the strength below which not more than 5% of the test result are expected to fall, and other characteristics of the concrete are flexural and splitting tensile strengths, and elastic deformation should also be considered, which is EC is equal to 5000 root FCK, and shrinkage of concrete in the shrinkage of concrete to be considered in the dependent to deformation, generally compressive in nature, and constituents of the concrete, size of member and environment conditions are the factors on which the total shrinkage of concrete will depend. Creep should be considered is another creep is another time dependent deformation of the concrete by which the continuous to deform, usually under compressive strength. The creep strain recover partly when stresses are released, and this is a long term deflection which will be added for the concrete to short term deflection to get the total deflection of the structure. And thermal expansion should be considered in the countries where it is very hot and cold climates. The coefficient of thermal expansion depends upon nature of cement and aggregate cement content, relative humidity, size and section. and workability and durability should be considered, which is been practiced in concrete technology. It should have good workable, there should be no more water content, and it should be the durability of concrete should be more. The durability performs satisfactory in working environment during its anticipated exposure condition during the service. Design mix should be there, that should be considered, and nominal concrete mix should be practiced, and batching should also be practiced. Okay, and these are the some of the important properties of the concrete. By saying this, I will complete this particular session here. We will meet up with some of the important factors and definitions which has to be known in reinforced cement concrete in next session. Thank you.